Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Introduction. In this video, we are going to discuss about models of communication networks and global state of a distributed system. Models of communication network. There are several models of the service provided by the communication networks, namely FIFO, non-FIFO, and partial ordering. In the FIFO model, each channel acts as a first in first out message queue, and thus the message ordering is preserved by a particular channel. In the non-FIFO model, a channel acts like a set in which the sender adds messages and a receiver process removes messages from it in a random order. The causal ordering model is based on the Lamport's happens before relation. Here, a system that supports the causal ordering model specifies the following property. That means causal ordering means for any two messages Mij and Mkj, there are two messages. If send of Mij tends to send of Mk, that means send Mj depends on that means linearly represents the send of Mkj. The receive of Mij also causally order over the receiving of Mkj. This property ensures that causally related messages destined to the same destination are delivered in an order that is consistent with their causality relations. The causality relation of the messages are described by the set of functions. Here the CO is a subset of FIFO is the subset of non-FIFO. The causal ordering model considerably simplifies the design of the distributed algorithms because it provides a built-in synchronization. The global state of a distributed system. A collection of local states of its component, namely the processes and the communication channels. The state of the process is defined by the contents of the processes registers, next the stacks, local memory, etc., and depends on the local context of the distributed application. The state of the channel is given by a set of messages in transit into the channel. An internal event changes the state of the process at which it occurs. The send event changes the state of the process that sends the message and the states of the channel on which the message is sent. A receive event changes the state of the process that receives the messages and state of the channel on in which the message is received. The global state of the distributed system is a collection of local states of the processes and the channels. The global state GS is defined as GS equal to union of LS, that means local states. For a global state to be a meaningful, that means the states of the all components of the distributed system must be recorded at the same instance. This will be possible if the local clock at processes were perfectly synchronized or if there were a global system clock that can be instantaneously read by the processes. A consistent global state, that means even if the state of the particular components is not recorded at the same instance, such a state will be meaningful provided every message that is recorded received is also the recorded as sent. Basic idea that a state should not violate the causality. A message cannot be received if it is not sent. Inconsistent global states are not meaningful in the sense of that the distributed system. That means a global state G is equal to particular union of local states, or that is the channel state SCI and process state LS must not include any message that processes pi sent after executing the particular event. The space-time diagram of a distributed execution. Here the global states G is equal to, that means the number of local states are interconnected and is consistent because the state of the P2 has recorded the receipt of the particular message M12. However, the process of P1 not recorded as it's sent. A global state GS consisting of local states is consistent. So all channels are empty except C21 that contains the message C21.